Hi everyone. Today I'll be giving a presentation entitled Signs of a Stroke with Smote. As you can tell from the title, I'm interested in the intersection between machine learning and healthcare. So today I'll be focusing on strokes. So what are stroke symptoms? You might feel the side of your face droop, or you might have speech difficulties, or even muscle weakness on one side of the body. In the worst case scenario, this can lead to death. So can we take data such as gender, age, BMI, for example, and predict whether or not someone has a likelihood of a stroke? You can click down on the link below to my GitHub, and you can play with the data directly through Google Colab if you want to. But for now, I'm going to show you what I've done. So there's a problem when we're dealing with stroke data, and just like, for an example, fraud data, there is an imbalance inherent in the data. And for fraud situations, there's about 1 or less than 1% of fraud and 99% of non-fraudulent data. And for stroke, it's no different. There are far less people who have stroke than those who do have a stroke. And what that means is that when you simply do machine learning on this type of data without first coming up with a solution, your model will learn very well about the majority class, but not so well about the minority class. So how do we deal with that? There are two primary solutions. The first is Smote. Smote takes the minority class, a class with many less samples, and it creates a synthetic samples, so brand new samples based on the original samples. Now this is one technique, but another is class weights. And as you can see for a random forest classifier or for logistic regression, they each have the hyperparameter class weight. And for example, I can say give the minority class 15 times more weight than the majority class. And these are two ways you can fight imbalanced data. So the goal of this investigation is to compare these two techniques, Smote versus weighted classes. The reason being is that Smote, because it creates synthetic samples, can be computationally more expensive, especially as the data gets larger and larger and larger, whereas weighted classes is a very simple fix. But does Smote offer enough bang for the buck? Or is weighted classes enough? So in order to test this experiment, we'll create a pipeline. And for pipelines, just like for regular data science workflows, we have to first determine what categories to drop, which to have as categorical, and which to have as continuous. Once we've done that, we can then impute data that's missing. For example, categorical data, we can say, just tell me the most frequent class and put that in. For continuous, we can say, let's use k-nearest neighbors to impute the class that you think, or rather the number that you think goes here. For randomized search cross-validation, this is a really cool thing that we can do in sklearn. We can take different estimators like logistic regression, random forests, k-nearest neighbors, and we can also give them different hyperparameters to check. So, for example, we might have logistic regression, and it might have a class weight where it gives more than, for example, 10 or 15 times more weight than it does to the majority class. In random forest, we might alter the max number of features. Or for k-nearest neighbors, we might alter, of course, k. And in this particular case, I wanted to have a very fast random search. So n iterations is equal to 50, and I have 3 cross-validations. As well, I've chosen the scoring metric recall because I think in this case, it's a matter of life and death. So we should be more concerned about false negatives than we should be about false positives, which is what recall optimizes for. So the results. In terms of class weight, it shows logistic regression as its estimator with these hyperparameters, and it gave us about 70% recall. As well, we can see precision fairly low, F1 kind of high for this kind of data, and balance accuracy also not terrible. You can look at the makeshift confusion matrix and see that it strikes a balance between getting the correct number of majority and minority classes. But Smote is a little different. It chose, for example, random forests with these hyperparameters, and recall is much higher at 100%. It does cost us precision though, which is to say that it gave many more false positives than class weights did. So class weights kind of gave us a balanced, nice picture. Smote gave us a very, very strong recall, which we may need in certain cases. So to conclude, class weights might be better when you need a little bit of balance between precision and recall, and if time is a concern, because Smote, on the other hand, is computationally expensive. But that computational expense might be worth it if the minority class has to be detected. So I hope you learned something from this. And if you like, please go to the GitHub link below, play around with the Google Colab, and you can change around some of the variables or try different things yourself. Thank you so much for watching.